Hi, in this video I'm going to show you guys how to find the distance between 2 points in space. What they mean by in space means in a 3D context. Okay, so before we look at an example of the distance between 2 points in space, let's look at something that is in 2D. So we have our XY coordinate plane, and then we have a point A at 1, 5 and a point B at 4, 1. Okay, so if I want to find the distance of vector AB, right? Vector AB and the absolute value bar, that means find the distance of vector AB. Okay, this is the distance of AB, vector AB. Okay, that's what this means. Okay, so this is just equal to simply we can apply Pythagoras theorem, or you guys could use the distance formula. It's up to you. So I'm just going to apply the distance formula in this case. So I will have 4 minus 1 squared plus 1 minus 5 squared. Alright, so I'm starting from this point, and then I'm going to say this is my point 1 and this is my point 2. So my x1 minus x2, right, this is my x1 minus x2, the whole thing squared, plus my y1 minus y2, right, my y1 minus y2, the whole thing squared. That gives me 3 squared plus negative 4 squared, which gives me, this is 9 plus 16, which is root 25. So the length of my vector AB is 5. Alright, so this is a 2D scenario, 2D. Not too bad, right? Basically we're just applying distance formula. So let's look at an example in 3D. Very similarly, they're actually very similar. So I want you guys to kind of pause the video and see what they want us to find. Okay, welcome back. So we have 2 points, point A and point B, and this is the coordinate for point A, and these are the coordinates for point B. And again, they want us to find the distance. Right, so here we have a 3D. We have a 3D space, and we have 2 points in the space. We're trying to find the distance between them. So again, we're not going to sketch it out. I mean, you could, but that would take us a long time. So instead, I'm just going to apply sort of similar concept, right, to the concept that we solved in the previous example, the 2D scenario. We're going to apply that to what we have here. Okay, so the distance between the 2 points, another way of saying that would be find the distance of my vector AB, correct? Same thing, right? So let's see what's my vector AB. Vector AB is equal to, so point A has coordinate of this, which means my position vector OA is equal to 1, 3, and 4, right? And for my point B, has coordinates of this, so my position vector OB is equal to 4, 2, and 7. So my vector AB would be AO plus OB. I hope you guys are now very comfortable with resultant vectors. Right? So my AO is just the opposite than my negative of OA. This is negative of OA, plus my OB is equal to 4, 2, 7. Okay. So negative of OA, I'm just going to multiply the negative to all of my XYZ coordinates. I get negative 1, negative 3, negative 4, plus 4, 2, 7. and that gives me 3, -1, and 3. So this is my vector AB, right? My vector AB is 3, -1, and 3. Now for me to find my distance, which is just the absolute value or the magnitude of my AB, vector AB, that is simply, I take the x coordinate, square that, plus the -1, the y coordinate, square that, plus the z coordinate, and square that. Oops, forgot to put a parenthesis there. Always use a parenthesis to help you out, to avoid making mistakes. So that gives me 9 plus 1 plus 9, so that's square root of 19. Okay, and you can leave it here, or if this is a calculator paper, normally they want you to round your answer up to 3 significant figures. So if you put out your calculator, you have 4.36. This is with 3 SF, 3 significant figures. Okay, I hope you guys understand the stuff that we're talking about here. It's not bad. We are just basically applying the sort of the distance formula that we learned back in middle school, and we're applying that to a 3D context, and that's it. All right, I'll see you guys in the next video. Bye.